We've got a robotic arm that will follow the movements of your right arm. You can either move your arm forward and back, up, down. You can rotate the elbow that you have, your elbow, and you can also rotate your arm just up and down like this. And then this arm down here will then follow the movements that you have and just position it in 3D space.
So it's tracking his arm. Essentially it comes down to just a skeleton. It grabs points at his wrist, his elbow, his shoulder, some points in his torso as well, and his spine. And that's what we're seeing here. Each one of those segments is connecting those. And using math in the program, we actually can find the angles between each limb and how he's bending all of his bones. This semester, we spent more time actually getting parts and putting them together, refining some of the math that we have in there, and making sure that there are also angle limitations on each one of these. So we make sure that, it can't bend so it would be pushing into the stand, or it basically can't break itself trying to move. It's been an all-year project. Last semester we did most of the planning, some of the preliminary figuring out what we were going to buy, buying some of it. We bought one of those motors to take apart just to get a better idea of how it actually works.
It's been an experiment, seeing how the motors can be used, seeing how the kinematics translate. That's the mathematics from taking your arm, in a picture of your arm that's mostly angles, and translating those to the angles that the arm actually has.
Inside each one of these, there's a little microcontroller that holds information like what its current position is, what its current speed is, how much load there is, basically anything you would want to know.
It's also been an experiment in seeing, how much power is required to make the same motions that a human arm does. Human arms are very efficient. Robots, sometimes less efficient.
When I hold the space bar, it's not sending commands to the motors, so we can change people out of frame, or if something went wonky and we wanted to just stop, we can hold this.
Actually just getting a sense for what kinds of power you need in the motors and what kinds of construction you need to make this possible is very important for research in teleoperation and beyond.